Hello everyone. In this lecture, I will discuss about the design of inverting amplifier. Before going to start this inverting amplifier, everyone should know about the amplifier. What is amplifier? Amplifier is an electronic circuit. It is going to amplify the magnitude of the signal. The real-time example of the amplifier is the microphone. The microphone is going to convert our voice signal into the electrical signal. This electrical signal to be amplified. The component of the electrical signal is the magnitude. The magnitude in the sense is the amplitude of the signal. This amplitude of the signal to be applied in this amplifier circuit. This amplifier circuit is going to amplify the amplitude of the signal. This is called as the amplifier. Okay. Here I am going to enter to our topic. First of all, what is inverting amplifier? An amplifier that provides a phase shift of 180 degree between the input and the output is called as the inverting amplifier. What does it mean? Here the input becomes the sine wave. The output of the amplifier is inverting of the sine wave. This is called as the inverting amplifier. Now we are going to discuss about how we are going to design this inverting amplifier. Here this is a circuit. In the circuit, I am using the operational amplifier. This operational amplifier has the two inputs. One is the inverting terminal, another one is the non-inverting terminal. Here I am going to design the inverting amplifier. That's why our input is given into the inverting terminal of the operational amplifier. Okay, the non-inverting terminal to be grounded. What is the next? The output. The output is connected to the CRO. Now, this is the feedback path. This is the feedback. This is the this feedback path. We are going to connect the RF resistor. This is the feedback resistor. This input side we are going to connect one more resistor. This is the R1 resistor. Now we are going to design what is the value. How we are going to set the gain of the amplifier. What is meant by gain? The gain is the output divided by input. How much we are going to amplify our signal. This is called as the gain of the amplifier. Now we are enter into the design. Here there is a circuit. In the circuit we have the two node. One is VA, another one is VB. This two node is called as the virtual node. This two nodes is called as the virtual node. Here this VA output becomes here this VA becomes 0. That's why this VB is also 0. Here VA is equal to 0 because of this is grounded. And VB is also 0 because of this is the virtual ground terminal. That's why the IB current is also 0. Next, how we are going to find the current across the R1 resistor? Here we are going to apply the Ohm's law. What is the Ohm's law? In the equation of the Ohm's law is equal to I is equal to V by R. Here the voltage across the resistor is V input. That means V in minus VB divided by R1. This is the current across the resistor R1. Okay. Now, in this equation, VB is equal to 0. Already we know because of the virtual ground, already VA is grounded. That's why VB value becomes 0. Here, this is the, we are going to substitute the VB is equal to 0 here. That's why the I of the current, that is I, the current across the R1 resistor is V in divided by R1. Next, how we are going to find the current across the RF resistor. Here this IB current is equal to 0. That's why this I current is passing through this RF resistor. The voltage across the resistors is different. How we are going to find this RF value? Here this I is equal to VB minus V out. This node the voltage is become VB. This node the voltage become V out. That's why VB minus V out divided by RF. Here this VB is equal to, already you know, this is 0. That's why I is equal to minus V naught divided by RF. Here we are going to compare these two equations. After comparing these two equations, we are going to find what is V out divided by V in. That means this is the gain of the amplifier. The gain of the amplifier is V out divided by V in. Just we are going to cross multiply this equation. The gain of the amplifier is, that means the gain of the inverting amplifier is minus RF divided by R1. This is the gain of the inverting amplifier. We mentioned that the minus sign is there. What is the use of this minus sign? This negative sign is indicating the polarity of the output is opposite to that of the input. Already I said that
In this inverting amplifier, it creates 180-degree phase shift of the input signal. That's why this minus sign is indicating the polarity of our input signal. That means is the opposite to the input signal. Okay, this is the gain of the inverting amplifier. Okay, next, what is the application of the inverting amplifier? The application of the inverting amplifier is first one is sign changer. If RF is equal to R1, what is meaning? Here the gain is become unity. That's why the only changing the sign. The positive input, the sign signal to be converted into the negative sign. Then scale changer. If you are going to change the scale, means we are going to change the value of the amplitude value of the signal become RF greater than R1 or RF less than R1. If you are fixing the value of RF greater than R1, means the gain become higher. RF less than R1 means the gain become lesser. This is the application of the inverting amplifier. Now, this is the practical approach. We are going to design an inverting amplifier with a gain of 2. Here I am assume that R1 is equal to 1 kilo ohm. Already we know that what is the gain of the amplifier. A is equal to minus gain. Gain is equal to minus RF divided by R1. Here gain is also is given. Okay, the gain becomes 2 minus RF divided by R1. Okay, the resistor value R1 becomes 1 kilo ohm. That's why the RF value becomes 2 kilo ohm. Here we are going to substitute this value to our circuit. Here this is the input voltage. Here 1 kilo ohm resistor. Here this is 2 kilo ohm resistor. Here we are going to monitor the output. By using the EveryCircuit simulator, I am going to demonstrate our output. Here this is the inverting amplifier. This is the operational amplifier. This operational amplifier input is given to the inverting terminal of the operational amplifier. This is the feedback. Here I am going to use the resistor value becomes 1. Here I am going to use the resistor value becomes 1 kilo ohm resistor. Here the RF value becomes 2 kilo ohm. The output, this is the input resistance value becomes 1 kilo ohm. What is the gain of the amplifier? Already you know the gain is equal to minus RF divided by R1. Here 2 kilo ohm, here 1 kilo ohm. The value becomes 2. That is the gain becomes 2. Here my input voltage. Here I am going to set my input voltage. Sorry. Here I am going to set my input voltage. The input voltage becomes 1 volt. What is our output? Input becomes 1 volt. The output becomes 2 volt. This is simple. Okay. Now I am going to simulate our circuit. Here we are going to look at this. There is a 2 waves. Okay. Wait. Here first. This is the input wave. This input wave, the input voltage becomes 1 volt. This input voltage becomes 1 volt. This is the sine wave signal. Now what is our output? Our output becomes inverting of our input, and also we are going to amplify with respect to the gain. The gain is equal to 2. That's why my output voltage becomes 2 volt. The sign becomes changed. This is the inverting. Okay. Now I am going to look. This is the I am going to add. Yes. This is my output. The blue line is our output. Green line is our input. The input becomes 1 volt. The output becomes 2 volt. This is the inverting of our input signal. Okay. Thank you.